Hi, I'm Barka Herman from StarTree. In this module, we'll take a look at some of the built-in detection algorithms in ThirdEye. StarTree ThirdEye ships with built-in algorithms so that you can start creating alerts using them right away. Some of these algorithms are threshold, percentage rule, absolute rule, mean variance rule, StarTree ETS or exponential smoothing, and matrix profile. Let's take a look at each one of these algorithms one at a time. The threshold algorithm is the most basic algorithm that ships with ThirdEye. This algorithm detects an anomaly when a metric is either above or below a predetermined threshold. This is great for signals that are mostly flat or they should belong within a certain range. It's really easy to configure and understand. However, it does not manage seasonality. Seasonality means that there's patterns of behavior that depend on seasons, and the seasons could be weeks, months, days, hours that follow a certain pattern, and threshold does not handle this very well. For example, store sales are really high during the end of the year as compared to January, let's say. That's a seasonal trend. Threshold is not a good solution for this. The percentage change algorithm is very similar to threshold, the difference being that it monitors if your metric is a certain percentage above or a certain percentage below your baseline. This is one of the easiest ways to manage seasonality, and it is easy to understand. However, it can get confused between seasonality and big trends. The absolute value change algorithm is also easy to set up and is an alternative to percentage. This is a little harder to set up because whereas the percentage, you can kind of say, okay, there's a deviation in percentage of the baseline. And absolute value change, you have to really know your data to determine the absolute value that you set up as thresholds. The mean variance algorithm detects an anomaly if your metric is above a maximum standard deviation or below a minimum standard deviation from the mean value. It's good if your signal is pretty flat and it has a lot of noise. The good thing about this algorithm is that you don't need to estimate the noise. It can adapt if the noise changes. The cons are it does not manage seasonality very well. StarTree ETS or exponential smoothing algorithm detects anomalies based on trends, seasonality, and noise. Under the hood, it uses Holt-Winters algorithm. The pros are that it's good at managing seasonality, trends, and noise. The cons are this algorithm heavily relies on historic data, and so it could be sensitive to data drift. An example of this could be book sales could be low because there's a trend in listening to audiobooks as opposed to reading books, or it could be a real low. The matrix profiles algorithm is the most sensitive algorithm in this group. It's actually heavily based on time series data, and what it does behind the scenes is that it's taking snippets of time series and comparing them to each other to figure out anomaly. It only works on seasonal data, and it can only be used in time series. It's very fast, and it's great at high frequency monitoring. So in other words, it's good at detecting anomalies within short bursts of time. However, it's not very efficient for long seasonal periods. In the next module, we'll take a look at the notification system.